Hi everyone. I am Marco, and Stefano is a colleague of mine. We are solution architects in Trento. That is, we are working for Affluent. That is a company. And you can find our reference here if you find anything interesting in the presentation. We are going to talk about TANGO. That is a European founded project. The name leads to the fact that as it takes two to tango, we believe that it takes two active actors in order to have a proficient interaction between human and machine models AI. So we are working into the TANGO project in order to build a modular Python architecture to serve models and offers API to users and case studies that bring aware humans of the importance of the interaction with the machine, a proactive interaction with the machine. The question at the on the basis of our work is who is in charge when critical domains, a human person has to decide how much should he or her or she trust the prediction of an AI model. So basically, when a surgeon, for example, received any recommendation from an AI model, can he or she be sure that the recommendation is the right to take for life or death decision? Can he or she be sure that the prediction is fair, is unbiased? And how can he or she interact with the machine in order to understand if there is something wrong or something that can be changed on these kind of predictions? And the answer that TANGO aims to give is that both are in charge, so both humans and the AI. And this is a choice that is made up by design inside the project. And that's why we are building with this great community of private institutions and universities and other kind of partners, creating a consortium of 25 participants with the strong belief that a transparent, fair, and rich with human feedback system is what we need in order to create a proactive interaction between human and AI. Everything that has been created, that is going to be created inside this project is released under the Apache V2 license, just to give opportunity for exploitation to companies that are interested in these kind of outcomes. The project TANGO is built up on 3 pillars on trustworthy AI. Basically, the first one is about fairness and ethics. So every prediction, every model has, it comes with a dedicated explainer that can give the human the sense of which kind of features was taken into consideration from the model itself in order to give that prediction. And these explanations are by design defined using a layer and explain for whom layer. So every prediction is specifically designed for the target audience. So it could be an expert, for example, a surgeon, but it could be a citizen asking, for example, for a loan toward a bank. So every explanation is suited for the target audience. And we are exposing what we call an hybrid learning API. So it's an API that allows users and humans to give feedbacks to the platform and to the models in order to these being aware of the context of a kind of conversation with the human and give better feedbacks. On the technological side, we created what we call the TANGO ecosystem. Basically, it's built starting from a TANGO library that is a set of method and algorithm that can implement this human-machine hybrid learning system, and comes with the explainer giving details on the criteria chosen by the machine to give the prediction. The TANGO platform, that is the main software component developed by our company, basically hosts machine learning models, supporting connectors to different MLOps platforms, and exposes a TANGO API layer that is a multi-purpose REST API that gives users the ability to authenticate and ask for the list of the model available on the system, ask for prediction, explanation, give feedbacks, and every kind of other interaction that a user can have with the platform itself. And everything is built, as I was saying before, on the open source software. This is our technological stack. So basically, there are many technologies in order to let microservices to be created and communicate over shared protocols. And we have a persistent layer, we have the API layer, and of course, we have all the stack related to the machine learning serving, and everything is detailed in this slide. And just to give you a glance of how this conceptual idea can be can have impact on 4 real use cases, I leave the floor to Stefano, a colleague of mine. Thanks.
Thank you, Marco. So we already have some pilot running on TANGO platform. In particular, we have one on maternal care triage, in which we are helping physicians through machine learning model to diagnose high-risk pregnancy. We also have some models in preoperative guidance for assisting surgeon during the aortic aneurysm treatment. I have more on that later. We are also working on credit allocation. So we are helping both the bank and the people. We are helping the bank in deciding if lend or not to lend the credit to a person, and also to be fair on that. We are also helping the people that want the credit with concrete action to improve their position with respect to the bank. We are also working with policy makers to help them understand the impact of their decision and to be also fair on that. Regarding then thrombus and aneurysm detection, we have an example. We have a couple of images. The first one is a CT scan. The second one is a CT scan in which the aorta is indicated by the red circle. In particular, we are building a model to help the surgeon to identify and properly segment the aorta before the operation. In this case, you can see that the aorta is partially clogged. The only part in which the blood can properly flow is the white one, the one in the yellow line. So most of the commercial model fail to find the full aorta and only able to find the part in which the blood can flow freely. So we build a better model that can find the full aorta when also is partially clogged or there is thrombus or aneurysm. So this will help the surgeon to properly size the tools and plan for the operation. So this is the first step of a bigger pipeline in which the surgeon will work with several machine learning models during also the intraoperative part. We have a quick demo. So we switch topic and we go to wine classification, so we don't have the problem to disclose personal information of patients. So we build a machine learning model that classifies the wine in white or red based on its characteristics like the acidity, the pH, and so on. But it is okay for our demo because the flow of operation is the same of other models, so we will call the TANGO REST API. we will make a call to the model. We also ask an explanation. So everything is done through the REST API, and we also build on top a small visual dashboard to have a better demo. May I ask for the video? Thank you. So first, you have to log in the platform with your account. Then you can see the list of the model. In particular, our model is the one which is called proto model for prototype. You can see that it has an explanator. You can select the model. When you have selected the model, you can see its signature, so its input, its output. You can also check the metadata, like who is the maintainer, where the model is stored. And then you can perform your invocation. So you are creating a session, you are uploading your data. A session is just a collection invocation, which are called to the machine learning model. You can create your invocation. You have to wait a couple of seconds to be parsed by the platform. So you can check the progress. And when your invocation is ready, you can see the result. So we have successfully classified a list of wine. Also, we ask for an explanation. So we can check if our explanation is available. The explanation has the same flow, so you can check if it's ready. And when it's ready, you can see your explanation. In this case, it's a dashboard that is not easy to read, but it's tells to you the characteristic of the wine that has been used to take the prediction. So this was our Tango platform. Everything is open source. You can find us on GitLab. Just search for Tango ecosystem. We also have a public open source documentation of the platform. And just for a quick recap, everything is under Apache V2 license, so you can fork it, you can build your own platform, you can serve your own model. And if you have any question, just drop us an email. You will find the address in the slide. Thank you.
Any question? Yes.
Hi, so thank you for the presentation. What I was interested is the clinical application. Specifically, what I'm interested in learning more about is the process of from the clinician to give the feedback to the model. So is it meant to be used during runtime? So for instance, the system is in place and during the everyday activity, the surgeon inserts the feedback, or is it like a separate pre-configuration phase that is separate from the runtime usage?
Okay, the idea is that there is the concept of a session, which is the list of, I will call it the conversation with the person with the model. So you can ask for a prediction, you get the result, you can put a feedback in the session, so the next request to a model can read the full session, including the feedback, and make another prediction, and so on. The specific flow will depend on the model. The wine classification is pretty simple, so it cannot handle any feedback. But for example, in the intraoperative case, you can have more going back and forward between the model and the person. So we don't have here the documentation of the REST API, but when you're creating an invocation, you can create an invocation of type feedback, in which you are sending a feedback to the model for the next request.